All right, guys, this is 2627 part 2. Yesterday we talked about just domain and stuff. Today we're going to talk about vertical and horizontal asymptotes. Tomorrow we're going to talk about holes and slant asymptotes, how to find all these things algebraically. And then Thursday we're going to spend the day graphing, because that's the part that kind of brings it all together and can be a little confusing. So when we talk about a vertical asymptote, okay, an asymptote is a boundary line. It's invisible. It is invisible, but it's a boundary line that your graph is going to get really, really, really close to, but not touch a vertical one. They can cross horizontal asymptotes, but your graph will never cross a vertical asymptote. So in this case, here's the parent function of a rational, right? The parent function for a quadratic is just your U-shape at the origin, right? Your parent function for a line is, well, that's not great, but it's right here through the origin, right? So your parent function for your rational graph is right here. I'm going to call these things boomerangs. I'm going to say, where do your boomerangs exist, all right? Because it's going to always be like funny looking pieces of graphs. It's not going to be one continuous thing most of the time. In this example, right, you have it says the vertical asymptote is the y-axis right here. So this is the boundary line, and if you notice, in red is your graph. Your graph gets really, really, really close to it, but never does what? Never touches it. Why is that? Okay, well, think about this. The y-axis, what is the x value right here? What's the x value right there? 0. So if I plug in 0 right here, what happens to my fraction? It becomes undefined. So your asymptotes are where the graph does not exist. It is undefined at that place. So that's why I said yesterday that your domain and your vertical asymptotes go hand in hand. Horizontal are going to also be boundary lines, but some of your graph can cross horizontal. It's not as specific. But vertical asymptotes, your graph will never, ever, ever touch. That is important because when you guys go to graph this on your test, you have to make sure that you never cross your asymptote. All right, here's just some notation you guys might see. As x approaches a from the right or as x approaches a from the left. If you notice, your a is just your asymptote, but your a positive, where are the numbers on the x-axis positive, on the right or the left? Right? So that's why a positive is right, a negative is left. So it's as your graph is approaching your asymptote from the left to the right, and versus as your graph approaches infinity from the left to right. Because look at this, if we think about our graph, right, we had our graph with something like this. So here is where your graph is approaching negative and positive infinity, and here would be where your graph is approaching your asymptotes. So that's just what that's saying. Again, just showing you where your graph is approaching asymptotes versus your negative and positive infinities. And just some more of our notation. As x approaches positive infinity, it's the right-hand side, negative infinity is the left-hand side. So let's talk about what some of these pictures look like, okay? We're going to call this one A over here. The first one is A. Let's look at our graph. Let's kind of analyze this for a second. All right, how many different sections does this graph have? There's 3 different sections. Do you see this boundary line right here? I know it looks like your graph touches it, but it doesn't. So do you see how you have 3 vertical sections here? 1 here, 1 here, 1 here. How many asymptotes do you have here? How many vertical asymptotes? How many boundary lines, God bless you, does your graph get close to but not touch? 2. Look at your denominator. What's the exponent in the denominator? Squared, 2. So if you had x to the first power, how many asymptotes vertically do you think you'd have? 1. Okay, so same kind of concept that went along with how many zeros are there in a polynomial, that sort of a thing. Look at your second graph. We'll call this one B. How many asymptotes do you see here? Just 1. But what do you notice? Can you guys see this? What do you notice at positive or at negative 3? There's a hole, okay? If you have a hole in a graph, and we'll talk about this tomorrow, look, we say that this is squared, yes? So it should have 2 asymptotes. But look at this. If I took this and I said x plus 3 in the numerator, what can I factor the denominator into? X plus 3, x minus 3? Yeah? So your 2 asymptotes in definition would be at positive and negative 3. But do you see how you have the same factor on top and bottom that cross out? When that occurs, instead of an asymptote being in your graph where you say, oh wait, the graph can't cross here, it's just a hole in the graph that allows your graph to continue on both sides. We'll talk about that a little more. But when you have factors in the numerator and the denominator that are exactly the same that cross out, instead of that being a vertical asymptote that they don't touch, it will be an area on the graph that creates a hole. And we'll talk about that a little more, okay? Does that make sense? All right, now we're going to look at some more graphs here. These are graphs with horizontal asymptotes. Well, how are these graphs different than what we just looked at? Look at your boundary line. Where is the boundary line? It goes horizontally, okay? Sometimes you're going to have horizontal asymptotes. Sometimes you're not, all right? We will discuss those situations when. But it's important to understand what these things look like when you graph them. So they're just boundary lines. They're not solid lines that you draw. They're just dotted boundary lines. And what it means as your graph approaches them. It's also important to figure out how we find them algebraically, which is what we're going to do here in 1 second. But if you notice here, your horizontal asymptote in this case, they're telling you right here, is at the x-axis where y equals 0. This graph actually crosses it. This graph, your horizontal asymptote is at positive 2. And this graph has no horizontal asymptote. And I'll explain to you algebraically the 3 reasons that that will happen. And you'll see in 1 second. So let's talk about how to find vertical and horizontal asymptotes. Okay, how do you find a vertical asymptote? We talked about this yesterday. You look in the denominator, you set it equal to 0. When you're finding the vertical asymptote, you're also finding the domain and vice versa. So in a case like this, if it says, what is your vertical asymptote? What are those lines, those boundary lines that go up and down that your graph is going to get close to and not touch? Well, where do we look? The denominator. So I have x squared minus 4 equals 0. So if I solve this, do you guys agree I get x squared equals 4, and then we do what? Take the square root. So I get x equals plus or minus 2. So if I were to graph this, and we'll do this later like as in tomorrow, you'd have a boundary line right here at positive 2, and you'd have a boundary line right here at negative 2. So your graph, your boomerangs are going to get close to that, but not touch it. But like I just said, once you find your vertical asymptotes, you're also finding your domain. Because what are the 2 numbers that you absolutely could not use to satisfy this rational equation? Negative 2 and positive 2. So how would you write your domain? Negative infinity to negative 2. Negative 2 to 2. And then 2 to infinity. So every time you guys find your vertical asymptotes, you're also finding your domain. Because think about it, if you plug in negative 2 or positive 2, what happens? This fraction becomes undefined. It's where the graph does not exist. So vertical asymptotes and domain go hand in hand. On your cheat sheet, you guys have this. I wrote this down. How do you algebraically find horizontal asymptotes? All right, we're going to compare the degrees of the numerator and the denominator. First of all, what is a degree? When I say what's the degree of this polynomial, it's the what? Highest exponent when written where? How? Standard form. Highest exponent when written in standard form. Okay, good. If you compare, all right, we're going to look at the numerator degree, we're going to look at the denominator degree, and we're going to make an inequality or an equality statement. We're going to say the numerator degree is greater than the denominator, we're going to say the numerator degree is less than, or we're going to say it's equal to. And those 3 scenarios will tell you what your horizontal asymptote is. And I'm going to show you this little in greater detail in a second. If the numerator degree, this first thing says, if the numerator degree is less than the denominator degree, your horizontal asymptote is at y equals. It's always going to be y equals because it's a horizontal line. If the degrees are the same, you take the leading coefficient of the numerator over the leading coefficient of the denominator. And again, we'll look at this in a second. And then if the numerator degree is bigger, it's no or none for horizontal asymptotes. So on your cheat sheet, I have that little thing in pink. This is how you guys are going to show me your work, and you have to get this in your mind. Some of you will understand, you'll see the correlation with if there's no horizontal asymptote, then there is a slant asymptote, which we'll talk about tomorrow, and vice versa. So let's just go through some examples of stuff. Do this. If you're asked to find the horizontal asymptote for this one, your horizontal asymptote, well, we're going to compare every single time, guys, write down N and D. You're going to compare the numerator degree to the denominator degree. In this example, what is the degree of the numerator? What's the highest exponent? 2. What's the degree of the denominator? 2. So is this greater than, less than, or equal to? 2 is equal to 2. So look at your little cheat sheet. Is it green, yellow, or red? Which star? It's y equals. If your degrees are the same, you take the leading coefficient of the numerator. What's the leading coefficient of the numerator? The leading coefficient, the number in front. 3. Over the leading coefficient of the denominator, which is 1. So your horizontal asymptote would be at y equals 3. So when you went to graph this, you'd have two verticals at -2, +2, and then you'd have a horizontal one here at 3. And then you could figure out, I'll show you guys how to graph in the next couple days. But you have to understand how to find these things. You're going to compare the numerator, denominator degree, and then figure out what goes. You guys might see here. Actually, so let's look at some examples here. Let's find your vertical asymptotes first. Vertical asymptote. Remind me again how to find the vertical asymptote. Denominator. Good. Denominator equal to 0. So when we find vertical asymptotes, we're also defining our domain. Think about that. So when I go to solve this, I have x squared equals 36, right? Take the square root. What's x equal? Plus or minus 6. So that means you have two vertical asymptotes, one at +6, one at -6. Once you have found your asymptotes where the graph does not exist, you've also found your domain boundaries. What's the domain for this? Any number in the entire world except for -6 and +6. So we would say -infinity to -6, -6 to 6, and 6 to infinity. When you find your vertical asymptote, you're also defining your domain, and vice versa, every single time. Now, in order to find your horizontal asymptote, it's going to be a y equals because it's a horizontal line, left to right. You compare the numerator degree to the denominator degree. If you tell me, I don't have to show work, yes you do, and this is showing you work. What is the degree of the numerator, guys? 1. What's the degree of the denominator? 2. Is 1 less than, greater than, or equal to? 1 is less than 2. So look at your cheat sheet. When the numerator degree is less than the denominator, what is the horizontal asymptote? At y equals 0. Side note, you might see this on website. What if I had like 6 over x squared? What's the degree of the numerator? 0, because this is really 6x to the 0 power. If you have a constant, the degree is just 0. All right, so we already have kind of a picture of what this would look like, right? You got a graph. Where are your vertical asymptotes? One over here at 6 and one at -6. I don't know why I wrote 7. Just like this. And then you have at 3, no, it was 0, my bad. I was thinking of the other one. And then right here at 0, you have your horizontal. So you'll begin to see where your graph breaks into pieces. And then we'll figure out where our boomerangs, where the graph exists. So let's look at letter B. Let's find our vertical asymptotes. When you find your vertical asymptotes, you're also finding what? Domain. Good. I'm going to say that a million times. So x squared minus 4 equals 0. X squared equals 4. So your horizontal asymptotes or vertical asymptotes? What are we finding now? Vertical. Good. All right. Plus minus what? 2. So if you know you can use any number in the entire world except for plus or minus 2, what would your domain be? Negative infinity to -2, good. -2 to 2, and 2 to positive infinity, good. Your vertical asymptotes and your domain go hand in hand every single time. So now if we're going to find our horizontal, remind me again, how do you find horizontal? What do we compare? The numerator degree to the denominator degree. All right, what is the degree of the numerator? 2. What's the degree of the denominator? 2. 2 is what to 2? Equal to. So look at your cheat sheet. When the numerator degree and the denominator degree are the same, what is your horizontal asymptote? What does it say to do? Look at your cheat sheet. Come on. Leading coefficient of the numerator, which is what? 3. Over the leading coefficient of the denominator, which is 1. So there's your horizontal asymptote. You guys have to have x equals or y equals. Vertical asymptotes are x equals, horizontal or y equals. Yeah. It's just saying a term of the numerator and the a term of, that's why I used n over d. It's easier to kind of understand. All right, let's go to the next one. How do we find our verticals again? Denominator. I keep saying the same thing over and over again, guys. You need the repetition so you understand where to look and how to look. So I say x squared plus 1 equals 0. Everybody with me? All right, so I have x squared equals -1. Take the square root. So x equals plus or minus what? I. Huh? What does that mean? What do you think that means if you get an imaginary number for your asymptotes? There aren't any. Good. There's none. There is no real number. Right? That's an imaginary. Think about this. If you wanted to know the domain, remember, domain goes hand in hand with your vertical asymptotes, right? Domain means what number could I plug in here that would make my denominator 0? Well, think about this, guys. You're squaring a number. So if I have a positive number and I square it, what kind of a number do I get? Positive, plus 1. Will that ever give me 0? No. What about if I plug in a negative number? What happens when I square a negative number? It becomes what? Positive, and then I add 1. Is that ever going to be 0? No. What happens if I plug in 0 in this case? I say 0 squared plus 1. Is that ever going to give me 0? No. So do I have any domain restrictions here? No. What would your domain be? Negative infinity to positive infinity. You don't have any domain restrictions because you're squaring the number. So when we talk about our horizontal asymptotes, how do we find those again? You compare what? Numerator degree to the denominator. What is the degree of the numerator? 1. What's the degree of the denominator? 1 is what then 2? Less than. Look at your cheat sheet. When the numerator degree is less than the denominator degree, what's your asymptote? At y equals 0. Good. So you guys, you might have a question that says like, right, look at these two. If you're going to find the horizontal asymptotes, that's all we're looking at right here in these two examples I just now made up. Horizontal asymptote. What do you do to find horizontal asymptotes? You compare what? The numerator degree to the denominator degree. Guys, what is the degree of the numerator? 2. Is it the first term? No. Make sure, if you don't rewrite it in standard form, just make sure you look for the highest exponent. So I have a 2 in the numerator. What's your degree of the denominator? 2. When those two things are equal to each other, how do you find the asymptote? It's the leading coefficient of the numerator. What is the leading coefficient in the numerator? 3. Just because 6 is in the front, that does not mean it's the leading coefficient. The leading coefficient goes with the biggest exponent. Yeah. I just made it up. I just wrote it down. What is the leading coefficient of the denominator? 2. So you actually have a line at positive y equals 3 over 2, 1.5. Just make sure, if you don't rewrite it in standard form, that you look at it in standard form. I would go like this, 3x squared plus 6x minus 1. So I see, oh, the squareds are first. Then I can see the number in front. It's a very, very easy mistake to make that you guys would put, oh, it's 6 over 2, which is 3. It's not. You have to put it in standard form first. So the second one that I just made up. Let's find the vertical and horizontal. All right, if I'm going to find the vertical asymptotes, where do I look for vertical? In the denominator. Okay, so x squared plus 9 equals 0. So x squared equals what? Negative 9. So x equals plus minus 3 what? 3i. What does that tell you about your vertical asymptotes if you get an imaginary number? There's none. Good. What does that tell you about your domain? All reals, negative infinity to positive infinity. When you have no vertical asymptote, your domain is always going to be all real numbers, negative to positive. If you're going to find the horizontal, my horizontal, I compare what? Numerator degree to the denominator. Show what you're doing, guys. What is the degree of the numerator? 4. What's the degree of the denominator? 2. 4 is what than 2? Greater than. So what's your answer here for horizontals? If the numerator degree is greater than the denominator, what's your horizontal? None. This one doesn't have any. And that could be the case. Whenever you don't have a horizontal asymptote, you'll have a slant asymptote, and vice versa. If you have a horizontal, then you won't have a slant. We'll talk about slants tomorrow. But you guys need to understand graphically what that means. An asymptote is a boundary line. It's not a definite hard, here is a line. It's a boundary. Your graph will never touch the verticals, might cross the horizontal asymptote, but it will never, ever, ever touch your verticals. And how do you find them? Vertical asymptote, you look in the denominator. Horizontals, you set the degrees. Compare them. You don't set them, you compare them. Numerator degree to the denominator degree. Yeah? Okay, cheat sheet. Let's look at it for a second. We've already talked about domain. We've already talked about vertical asymptotes. We've already talked about horizontal asymptotes. You guys need to understand that to find the y-intercept, you plug in 0 for x. And to find x-intercepts, you just look at the numerator, set it equal to 0. Tomorrow, we're going to cover slant asymptote and holes. What that means graphically, we'll explain it. We'll start graphing a little bit, but Thursday in class, I'm going to give you a few questions. We're going to go through it. We're going to find vertical asymptotes, horizontal, slant, x and y intercepts, all that good stuff, and then we're actually going to graph them because you're going to have to do that on your test. So just make sure we get enough practice doing that, okay?